welcome to the course Disaster Recovery and Build Back Better. My name is Ram Satish. I am Assistant Professor in Department of Architecture and Planning, IIT Roorkee. Today we are going to discuss about guidance to DRR, Disaster Risk Reduction. So here today in this lecture, what I tried to do is I tried to compile, at least showcase different kinds of manuals or which is providing some guidance. It could be a thumb rule guidance, it could be do's and don'ts, whatever you call it, but it is showing some guidance. Guidance to what? Guidance to whom? And guidance to which context? So when we say guidance to whom, this could be for the people who are working on the shelter practices, whether it is an architect, whether it is a civil engineer, whether it is. So basically there is a group of built environment professions involved in the shelter recovery, especially in the humanitarian context. And the second aspect is it is talking about certain principles of do's and don'ts, what to do and what not to do, which is better. It's a very generic principles which is showing. It is not specific to the site, but it will actually show some guidance to people working either on hilly areas or floodplain areas or in earthquake prone areas. So it is sometimes it is also specific to a disaster. So this particular manuals, earlier they were too technical to work on it. But as the time moved on, the visual aspect has improved quite a lot. And because it has to reach to the common man, the most of the target group population who are often affected by the disasters, they are probably from the vulnerable areas, especially from the remote rural areas, where you hardly get any technical manpower. So how this kind of guidance can show, and these manuals can show a direction for the layman even to understand that what to do and what not to do and how to do. I'll be showing a few guidelines and which has been developed by different agencies, and what are the focus lies on and how they have tried to demonstrate, and what is that they are trying to give an information or to a guidance to the shelter makers. Now, for example, this was a kind of guidelines which has been developed for earthquake resistant design and detailing, and this is developed by EERC, which is the Earthquake Engineering Research Center, International Institute of Information Technology. This is where the IIIT in Gachibowli, Hyderabad have worked, and they have also set up some lab on it, and they have worked on the simulations part of it, and finally they have concluded with various evidence based analysis. They try to develop a small manual about which gives a kind of thumb rules. For example, how it will inform the built environment professionals. For instance, an architect or a civil engineer who is constructing the housing. When we talk about the very basic form of house compositions, planning of a house or a dwelling, here we follow certain elements of architecture, and we follow certain principles. We apply the principles of architecture, and then we compose. Basically what we try to do is we compose, and in this composition process, what in terms of the earthquake nature is concerned, so they are recommending that try to avoid the asymmetrical compositions in an earthquake prone areas. And because these asymmetric buildings undergo torsion and extreme corners are subjected to very large earthquake forces. So obviously if you are talking about wings and keeping many offsets in the buildings, obviously there is a tendency that there will be tendency that these corners can break, because most of the damages which we have noticed in the past earthquakes, they mostly occurred in the corners. So that is where they try to suggest, try to avoid the asymmetrical buildings forms. Some of the other guidelines which they talk on the site selection. So when you are constructing something of a building, try to avoid the sufficient away from the steep slopes. Okay, and also in many cases what they do is when you are cutting down and filling the soil, especially the filled up soil, try not to make the foundations in this, because that is going to have an implication that it might come down and the whole load will collapse. There is a possibility that the building may collapse at the time of earthquake, because the forces, it cannot be very much stabilized because of that filled soil. And the shape of the building, they also suggest that very slender buildings should be avoided. So they also talk about the ratio, height and breadth should be less than 4. And also the inverted pendulum type buildings are unstable. So they always go with a kind of pyramidal type, so that the load is distributed. And whereas here it becomes difficult, the more height you are going up, it becomes difficult. And there is also the wind movements, there is also the lateral forces which are actually applied on to the whole structure and how it can resist. For instance, in Hyderabad, this is called, we call as, a nickname is a kind of Malakpet Buj. It's a kind of tall tower which has been built in a place called Malakpet, and you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 1, 2, 3, 4, 5, 6, 7, 8, 9, and with the ground floor, G plus 9 floors. And look at the volume of the building and look at the height and breadth of the building, and also look at what is on the adjacent sides. If some slight movement happens, now you can see that the next building is also coming on the similar heights. So now when certain towers are not considering, and they are not leaving any setbacks, and they are not leaving out any proportions, how the proportions with the height and breadth has to work. And this is where despite of the building regulations and what we have, the building bylaws, the permissible limits, yes, he is going within that permissible limit, but is it really worth enough, and whether it can resist that earthquake forces during the time of an event? So these are all some mismatches between what the building bylaws permits and what the earthquake guidance is telling. So there is a consensus, there should be a consensus between the bylaws and as well as the structural measures which the guidance manuals suggest. And similarly, when we say about the sudden change of lateral stiffness should be avoided. So when you are talking about the, when we are improving the height, so you should not increase it so that the sudden change of this lateral stiffness, because it has to avoid this part, otherwise there is a chance of collapsing. Similarly, in the projections and overhangs, so now just on the two stills the whole building has been collapsed, so this is very unstable, and so you need to have some kind of support system. That's how in order to have this kind of large overhangs, and then you are keeping load over a load and it may collapse. That's what he says, large overhangs and projects attract large earthquake forces. Similarly, the separation of dissimilar buildings. So when you are talking about the two different buildings, at least you need to, if it is a load bearing structure, you should have about 15 mm, and if it is an RCC frame, it should have 20 mm, and if it is a steel frame, it is about 30 mm. So at least this much gap should be left, because in order to avoid the collision between these adjacent dissimilar buildings, and that should have a minimum gap. Also, we should try to avoid the heavy mass at the top, because normally in the previous building culture, what they do is they try to build the overhead tanks to heavy volumes. But then during the movement, that is where it can also give a load, and it can also be a cause of that particular, when the movement is happening, obviously it can bring instability in that whole structure. So that is why what the advice is, you can have, instead of a large tank, what you can do is you can have a smaller tanks and the water distribution system could be connected, so that at least on that note you will not get any load aspects into it. Also, these technical manuals also talks about even the type of reinforcement, the connection details, so for example, they will talk about when we say the 1 feet beam, or that is where the reinforcement, basically how even the stirrups, how the clear cover has to be done. So the stirrup details also have been given as a guidance, how to mold them, how to consider what to do and what not to do. So after the tsunami, Government of Tamil Nadu, and with the help of Revenue Administration Disaster Management and Mitigation Department, they've also developed certain guidelines of reconstruction of houses affected by tsunami in Tamil Nadu. I'll show you a brief about what is there in the guidelines, and like that I'll be keep discussing about various guidelines. Now, they also talk about the cyclone zones, the wind and cyclone zones. For instance, this is the most high damage risk zone, which is more towards the Chennai, and this is the moderate, and this is much more beyond the cyclone aspect. But whereas in the earthquake, if you look at it, that is where this zone is more of an earthquake vulnerable zones. Also the hilly areas about the Nilgiris and a little bit of the Kanyakumari and the part of Kerala where the Western Ghats are also meeting at some point near Nagarkoil and other places. So these are the vulnerable. So, but one has to look at, when you see these kind of maps, they should not look at in an isolated manner. You have to also consider the multi-hazard prone aspect. So the same district, it might be cyclone, like for instance, if you look at this, it is also a cyclone prone, it is also an earthquake hazard zone. So in that way, one has to look from that perspective. And similarly, they also talk about the CRZ regulations, the implication of the CRZ, which is a coastal regulation zone implication. Like they talk about at least 500 meters from the shore and plus 5 meters from the mean sea level. So, they also talk about, because if you don't raise it, either you improve the height of the plinth of the building so that if the water comes, if there is a tsunami, then, or you raise the plinth so that at least this will be taken care of. And similarly, there's about the desirable conditions. When you talk about building near a ridge attracts high wind velocity, but buildings in valley is protected from a high wind velocity. I think in this case, I would also bring a counter aspect of it. It is also depends on how the makeup of the hill and the landscape is all about. Because even in sometimes, imagine if you have another hill that becomes a tunnel effect, so in that way, the wind will get channeled much fierceful. So null shielding from high wind due to absence of barrier, because that is where you need to talk about the landscape. How we can promote the landscape so that it can actually reduce the velocity of wind and can have a control mechanism over there. And as I discussed to you as an earlier report, which talks about the planning requirements of what kind of plan forms. Don't make an asymmetrical plans, and also don't have too many offsets. Here this is like too many. It's asymmetrical, but still it's too many offsets in it. But then either try to make more of a defined shape, because that is where you can even have a diagonal bracings, you can have some kind of support system. So it is at least bound to it. This plan should be square or rectangular. If it is rectangular, then you need to have a kind of intermediate support systems into it. Now, asymmetric buildings with empty pockets are more vulnerable to damage, because don't leave these empty pockets. So try to fill that. And that is where these are more stable, the symmetric buildings are more stable. And also when we say about the row house planning, the row house planning also creates wind tunnel effects, because the moment your houses are one step to another next to the shore, and then it channels the wind, and that is where it can damage the edges of the walls or the corners. So that is where you can even, now even the zigzag planning avoid wind tunnel effect, right? So how actually you can actually see about how you can actually give a little bit of vastness and then reduce it. So the zigzag pattern as well can have some control. It depends on how you are actually orienting it. And similarly, the long face of the building facing the wind direction. In fact, if you ever visit in the coastal villages of Tamil Nadu or in the coastal villages, most of the times your short face is of the building is facing the wind direction. And whereas in horizontal face, because that is where they have less number of openings, and either that if they are facing that side, then they will have less number of openings, and otherwise if they mostly they orient. So the whole building pattern is like you have the seashore and you have these. So the buildings, the shorter side will face the seaside. So that is how they are oriented. And similarly, in terms of this particular manuals also talk about the quality control. In terms of quality control, it is also talks about the material, what are the ratios we have to include. So when we say about do not use cement and sand less than 1.6, okay, 1:6. So for 1 cement and 6 part of the sand, so you should not make use of the combination of this mortar not less than 1:6. Either it is recommended to use 1 sand, 1 cement and 6 sand, or 1 lime with 3 sand, or 1 cement, 3 lime and 9 sand. So this is a kind of mortar mixes which normally the guidelines do recommend. And at the end of the day, all these are coming from the proper IS code, but these are only a thumb rules. And many of these manuals, when they are published in English, it becomes very hard how a local mason can understand it. So that is where recent efforts have been done by architect Benny Kuriakose after the recent Kerala floods. So what he did was he developed a manual for retrofitting and flood resilient design for flood affected areas in Kerala. So the Malayalam version is already printed and the English version is on the process, but still I could show you some images of what his work, and it's very diagrammatic and very illustrative work. He looks into before coming into the solutions, he actually explains the situation of how the causes. This is a very important aspect of developing any guidance. So one has to understand the consequences of these disasters, and especially what are the causes, root causes for it, and whether it is in the form of orientation, whether in the type of construction, whether it is a sighting out, So this all, for instance, here you have these normal setup where you have the river level and all of them have built on the top, on the mountains, and then the average flood level in case it might have reached here. But then because after the construction of dams, people started construction near the river beds, the change because they know that the water is not coming very frequently. That's how they started coming down, and they even started constructing the houses near the river beds. So that is where you can see that in 2018 the Kerala flood have almost submerged 3/4 of the houses even on the top. But even after the flood process, still certain, because you see that when this kind of images are formed, even after that these low lying areas are still left over with the water, and that is what creating some endemic and epidemic diseases which are spreading, and that is even much bigger disaster. Okay, so it takes so much time, and also the water has stayed back even after because even after the flood and even after the rescue process, still in the same story in Kashmir, the water has stayed back, and because the main issue is lack of proper drainage systems. The Chennai floods, it is the same, because that is where the planning situation, the service infrastructure orientation has to be addressed. Then when the water keeps coming into these areas, obviously there is also an aspect of there is a difference in water levels. For instance, the amount of water it enters and the amount of water outside. This is almost 8 cars the load which is coming of the 8 cars worth of load which is pushing this wall, and this difference in water level creates the pressure on the wall. This difference is creating the pressure, and that is how there is a major scope that this wall might collapse, right? Because there are two forces, one is a smaller force, one is a bigger force, and it is pushing. It's almost about 8 cars worth, and then obviously that balance is missing. And even the water goes, so it takes out the topsoils. The moment the topsoils are going out, because the foundation we are talking about maybe 1000 mm, and obviously this can loosen and this can change the soil conditions and movement beneath. So in that way there is a possibility that these houses may collapse. So that is what we have seen in those videos. Also the velocity of the flood water, because the moment you are keeping the same thing what the other manual of the tsunami is talking, the moment you are making these row houses like this, that is where this is going to create the pressure, intensify, because that is where the it's a kind of bottleneck process. So the water, and then it affects this whole damage process, both the walls, and also it can affect the foundations. So these are a few glimpses of the reasons, but there are many other which he have explained in his manual. And in fact, how to retrofit these things, because there are some solutions, not only the causes for these aspects, but you also have to talk about the solutions. So for instance, when we say about solutions, how to retrofit it, what are the techniques one can use? For example, in architecture, we might have studied shoring, and you might have studied about raking shores, and you might have studied about underpinning. These are various techniques which we learn from our architecture, building, construction subject. But then this is one where you really apply it, because this is where, in order to protect this wall and during the restoration process, you need to apply these shores, so that you need to give a kind of temporary support until the restoration is done or retrofitting is done. Now there are different ways of, he explains different scales of these cracks. For instance, if it is a smaller crack, what you do is you're making a V groove and remove of loose particles. Then insertion of stone chips in this. So there's a galleting technique sort of thing. You keep the stone chips, and then fixing a chicken wire mesh all along, and then filling with the mortar and non-shrinkable cement grout. So in that way, curing it for 15 days. The curing is most important part. No, everyone ignores this curing part. It's only not just only the plaster part of it. So these are a few techniques which he comes up with, how to retrofit these things. And then till now we have discussed our discussion about the giving the manuals and guidance from a very disaster focused, whether it is an earthquake focused, whether it is a tsunami focused, and it is a flood focused. But in Beni Kuriakose thing, we have observed that these are being translated in the local language, and illustrated more in a diagrammatic manner, explaining the cause and the reason for it and the impact of it. So there is an issue, there is a cause, and there is an impact. And as a result of this, how we can deal with this as a solution, what are the different ways we can deal. So that is how these manuals have been framed. But then when we talk about the manuals or the guidance, yes, we do understand they show a broader picture of it. But then what about whether it is a state government of Tamil Nadu, whether it is engineering structures, GSDMA, where is a Gujarat State Disaster Management Authority, which have issued some manuals for retrofitting the buildings or reconstruction. But the whole state is very diverse. It has its own regions, it has its own unique geological and geographical and topographical conditions. It has unique landscape. It's a very diverse landscape. If you take Gujarat, the state, you have the desert part of it, you have the bunny grasslands part of it. Similarly, in Tamil Nadu, you have the coastal Tamil Nadu, you have the Nilgiris as a mountainous place. So one has to understand that each state is being subcategorized by different cultural geographies, which is not only the geography, but they also vary with the cultures. the moment culture comes into it, it can talk, it is reflected in the building practices, whether it is a type of construction, whether it is an alignment of a house, whether it is the dwelling typology and the belief systems. So that is where there's been an effort by the Ministry of Rural Development and Government of India, where they have issued a compendium of rural housing typologies of 13 states. This is called Prakriti Hunar Lokvidya under the Pradhan Mantri Awas Yojana Gramin scheme. This has been compiled as a kind of compendium of different rural housing technologies. And UNDP and CBRI and IIT Delhi, and they have all been partners of it and technical institutions. They have already covered Assam, Chhattisgarh, Himachal, Jharkhand, Manipur, Odisha, Rajasthan, Tripura, Uttar Pradesh, West Bengal. So I'll just show you, I will not show you everything, but I'll show you one state, what is the pattern they have tried to address. First of all, the design of the manual itself is the important thing when you are developing a guidance. For example, this is a zone A. This is how the coding is worked. So now it says UPA01. UP is Uttar Pradesh. A is what is a zone, and within the zone you might have 2-3 typologies. So that is where the typology number. So for example, when you say the state map, the state name, and then zone 1, 2, 3, 4, 5 like that. So this could be done by A, B, C, D, E zone, and then within the zone you have 1, 2, 3, 4 typologies. This is how it has been organized and how one can read this document. I'll show you one example of it. For example, you take the Assam state, where you have the zone A is here and the zone B, okay, and the zone C, which is towards the Bangladesh and the Manipur side of it, and you have the zone D and zone E. So this is how, and they're all classified by vulnerability to natural hazards, physiographic and access to building materials, and the cultural compatibility. So here they have even described what actually this zone A comprises of in the high vulnerability, especially to floods, and what kind of floods they are talking about, what kind of riverbank erosions they are talking about, and it is also talking about what kind of elevations and the forest cover. So that's how the descriptions of each zone has been given. Then in the zone A, where we talk about here, this is the zone A, and it is based on the high vulnerability and medium vulnerability to cyclonic storms and mostly low vulnerability to riverbank erosion. So here, this particular typology, this is the typology of a house where they try to document it, and this responds to brick masonry houses with 3-inch walls, which are most common. And because this is an effort how one can validate these rural housing typologies which are already existing, So how structurally one can validate how, so that earlier whatever the rural technology exists, they try to ignore it and they try to give their own uniform and standardized solution. But this is an effort how we can bring that local character still and how we can validate those techniques. Now it says about the plinth, the high plinth design and a sloped roof. It also talks about the foundations and the wall finish, plinth, roof structure and the floor, and it's all talking about the recommended specifications of it. Then a typical dwelling unit, like this is a 01, this is one typology, and you can even think about how the basic dimensions which are existing and how one can actually understand that 6 feet 3 inches, the span between 6 feet 3 inches, and that is how a framed structure could be also thought of. And here you can see the half brick wall in cement mortar in 1:4, and whereas if it is a brick pier, 10 inches by 10 inch brick pier, and for each this is a 6 feet 3 inches span you are getting, and also 3-inch diameter bamboo post embedded in concrete slab. So basically you have the concrete, and then this is a bamboo post which has been embedded with it that acts like a reinforcement. So this is a basic understanding of the plan forms of it. And then it goes back to the heights and the material components in it. So how the wooden purlins works, how the collar beam works, so how the brick foundations, how they have to. So it gives the more technical details of how one can construct in this format. Then comes to the cost estimate, the cost estimate for zone A, design 1. So when we talk about cost estimate, it covers excavation, brick soiling, PCC, brickwork foundation, brickwork above plinth, concrete, what is the ratio we are talking about, 1:1.5:3. Always it's a multiple of the aggregates. And the reinforcement steel, truss, and then GCI sheet and door, window, cement and plaster. So in that way, they have been composed with how much it is going to cost per room, kitchen, veranda, and total is this much. And how do they calculate it? When you talk about, this is where the integration of quantity, pricing and specifications will come into the picture. Also, one will have to understand the labor rates of that region. If it is a Delhi area, you have to talk about Delhi's analysis of rates, DSRs. And if it is a CPWD agency, then you have to analyze. At least there are different ways how one can get these rates, whether it is a labor rate, whether it is a material rate, whether it is a steel rate. If it is 1 ton, how much steel it is working. If it is brickwork, how much brickwork is costing, and for this amount of brickwork, how much labor is worked out. So this whole thing is a kind of a cost breakup, so that at the end you are able to come up with some kind of guidance. From 1,64,000, one is able to get this kind of house, right? So in that way, this is giving you a detailed version of what to do and how we can bring these rural typologies into the mainstream practice. Similarly, there were efforts in Pakistan, in countries like Pakistan. There have been a guidebook for technicians and artisans. They call it as artisans. Like in India also, in Himachal and as well as in Uttarakhand, we have Daji wall constructions, where it can go of the 1 and 2 story earthquake resistant houses, where you have the timber frames and the embedded, whether it is a stone embedded, whether it is cobbles or pebbles, whether it is a flint, whether you are filling it. So they have developed the technical manuals of doing this Daji constructions. And also the retaining walls, if you are constructing in these hilly areas, what are the methods one has to approach in constructing the retaining walls, and especially what are the principles we apply in subdividing these Daji wall constructions, because there is a timber studs and which are embedded within the stone gabions sort of thing, or it could be mud plastered as well. So this is where they even talk about the nail sizes, they even talk about the spacings to it, and now here 1 inch by 4 inch. They are even talking about the length of studs, the dimensions of the studs, the volume of the squares, now some of the technical details which has been given some guidance to these local carpenters or the artisans who are going to work on these Daji wall constructions. So I mean, this is a brief about these manuals. Of course, there are many manuals in different languages, but I tried to show you from the Indian context and probably Pakistan I covered. So this is good enough for an architect to look into some kind of thumb rules for a low cost housing as well. And one has to understand that giving it in a local language, how this particular technical information can reach to the common man and the layman to understand it, is one of the important objective of these manuals. I hope you are familiar with these manuals now and the guidance. Thank you very much.